Hello, discrete math fans. Our next topic is rooted trees. In real life, if you have a physical tree, one with leaves and branches and bark, a physical tree is rooted. There is a spot from which the tree grows. And in a similar way, a family tree that shows the descendants of a particular person is rooted. Now in mathematics, we'll talk about rooted trees, where one vertex is distinguished and is called the root. Given any other vertex v in the tree, there is a unique path from the root to v. The number of edges in that path is called the level of the vertex, and the height of the tree is the length of the longest such path. Now, physical trees grow upward from the ground. The root is at the bottom. However, in math, we tend to draw trees with the root at the top, and then the tree will grow downward. All right, so this is a formal definition of a tree. It talks about a lot of the things that we mentioned before. There's the level, the height. Then there's the idea of children, that if you take any root or internal vertex, then the children of that vertex are all those vertices that are adjacent to v and farther away from the root than v. And then the opposite of children is parent. And then two vertices that have the same parent are siblings. And then you can talk about ancestors and descendants. An ancestor is any vertex that's closer to the root, and it can be more than one level away. And descendants are where you have to go farther away. Well, let's look at a picture. We're going to mark the root in red, and we'll also put an arrow to indicate where it is. Here is a rooted tree. First of all, we know it's a tree because it has no circuits, and we've labeled one of the vertices as the root. Here you can see the various levels of the tree. This particular tree has height 4 because the highest level is level 4. By labeling a few of the vertices, we can talk about some of the language associated with rooted trees. We can say that A is the parent of B. A is also the parent of C and D. B, C, and D are all siblings. Let's now talk about the word descendants. All of these vertices here are descendants of A. We could also talk about the word ancestors. How about the ancestors of B? These are the ancestors of B. Okay, that's all for now.